All right, we're going to look at our final BB, which is BB12, match quadratic functions and graphs. I have seen that a lot of you have done this already and you've picked up really quickly, which is great. So basically on this first one, we want to use what we know about the A term. So this A term has a negative in front of it, and we know what negative people do. They frown. So that means that the quadratic is reflected, meaning it's flipped over. So normally when we have a x term that's positive, it smiles. So positive people smile, we know that happens too. So we're going to move x squared plus 12x plus 39 here, and negative x squared minus 4x minus 1 is here. And if you really feel like testing your knowledge, you could find the vertex. So we would do x is equal to the opposite of b. So the opposite of b would be 4. Divided by 2 times a, so negative 2. 4 divided by negative 2 is negative 2, which there it is. There's our x equals negative 2. All right, same thing here. We pretty much don't have to know very much. We could use the fact that this is a positive a term, so we're looking for the quadratic that smiles at us. And C is the y-intercept, so we're looking for the quadratic that crosses the y at 6, and this is the one that doesn't. This one doesn't. Now, also, since we've learned how to factor, you could see if you factored these, where the roots would lie. You could also use that. Here we have f of x is equal to negative 2x squared minus 20x minus 5, which means that we have roots at negative 5 squared, which means really we have, here's an interesting term for you, a multiplicity of 1, meaning it just hits the x-axis and it bounces off. We also know that this quadratic is turned downward. The other quadratic is also turned downward. But if we use the transformation information that we learned earlier this week, we know, oh, on g of x we've got a reflection over the x-axis, so it's turning down to a frown, and it's been moved down 4. So we can move this here. Also, this is written in vertex form. Our vertex for f of x would be negative 5, 0, and that's the vertex here. So on f of x minus x squared minus 2, it's a quadratic that's been reflected. It's frowning at you and moved down 2. So we see that there. And this one shows you the zeros. X plus 1, x minus 4. So we know a 0 is at negative 1 here. And we know a 0 is at positive 4 here. We also know that the x-intercept is 4. Not the x-intercept, sorry, the y-intercept is 4, and we know it's reflected, so it's frowning at us. So look at all of that information you could tell just from this one equation. If you still weren't sure, you could take the axis of symmetry and find that out by dividing 3, or the opposite of b, which is negative 3, divided by 2 times negative 1, which would give you 3 halves. And if you look right here on this quadratic, there it is. There's your vertex right here, or the axis of symmetry equals x is equal to 3 halves. All of this information that you've already learned, and now you can use it to find out how the graph should look. So I'm going to continue to do this and see if I run into anything that's really weird. All right, so let's take a look at the next set. Everything else has been 2 up to this point. We still are matching each quadratic to its function. So I've kind of made a little chart here. And what I'm going to use this chart for is I'm going to write down everything that I know about each of these functions to help me pick which picture would be best. So first thing I know about this is function f of negative x, or f of x, sorry, is that it's reflected. So that means it's frowning at me. Also, I know that there is no h, there's no parentheses here, so I know it's gone down 5. All right, so also what I would know then is that my vertex would be, since it hasn't moved left or right, is 0, -5. Okay, that's about all I know about that. Oh, then I could find the axis of symmetry too. So the axis of symmetry would be the opposite of b. There is no b, so that's 0 over 2 times -1. So 0 over -2 is 0. So I know that my parabola is going to be split in half at this 0 point. So x is equal to 0. Okay. All right. Now, let's see which one we find based on that. If we look, well, this is reflected, this is reflected, this is reflected. But what we do know is that our vertex is 0, -5. So I'm going to pick this one. All right, let's go on over to g of x. What we also know is that it's reflected. If we look here, this is in vertex form. It's moved 9 to the right, but hasn't moved down at all, so down 0. So then that means that our vertex would be 9, 0. Our axis of symmetry would be, let's see, opposite of b, which is -18 over 2 times -1. So it would be 9, which makes sense because if the x value in my vertex is 9, that means my axis of symmetry is also 9. Also, if we look at our zeros here, then that means that my 0 would be +9 as well. So let's see which one we have like that. Well, this one obviously isn't it because our vertex isn't 9, 0. This is the only one where our vertex is 9, 0. So I'm going to drag that down here. All right, we've got 2 left. Well, that's kind of process of elimination. We don't have to do much with it, but I want you to get used to this process. So here I was given the zeros. So I know that one of my zeros is going to be 3 because x minus 3 equals 0, x equals 3. I know one of my zeros is going to be -6. Let's see. Oh. Wait a minute. Did I write this down right? And then you said that the zeros on that one are, oh, I wrote it wrong. Okay, that makes sense. So my 0 here, x minus 6, is going to be x positive 6. So we could just look at the zeros. Looks like this one right here. We could also check, okay, what is our axis of symmetry? It's the opposite of b divided by 2 times -1. So that would be positive 4/2. 4 1/2, which is the same as saying 9/2. Okay, so if we look here, 9/2 is equal to 4 1/2. Well, that looks like it right there. What else could we look for? It looks like as this goes down that eventually the y-intercept will be -18. It's reflected over the x. So reflected, we know that too. So this would be the right choice. Well, the only one left is this one. So we were told what our 0 was. X minus 5 equal to 0. X must be 5. We're also told that it's smiling at us. Or we could look at the axis of symmetry. So opposite of b divided by 2 times 1 would be 5. And that makes sense. So our vertex would be 5. And then if we put in 5 for all of this, that's, let's see, 5 squared is 25, minus 10 times 5, which would be 50, that's negative 25. Negative 25 plus 25 is 0. Well, that makes perfect sense now, doesn't it? So there's all different ways that you can discover what graph goes with what. You just need to use all of the tools that you have, everything that you've learned. Range, domain, axis of symmetry, zeros, y-intercept, x-intercepts, all of that. And that will help you. Look at that, we got it right. And then there's some more that are just like that. So I'll leave you to it. Have fun. Remember, we have Power Hour from 12:15 to 1:30 if you'd like additional help. Tutoring is from Tuesday, Wednesday, Thursday from 4:30 to 6:30. All of those items happen in Math World. Friday by appointment. And if you just need a quiet place to work, you can always come in my room at 7:30 in the morning, work until class time. All right, see you later.